While complete elimination of lightning damage isn't possible, a well-designed and implemented lightning protection system, or LPS, can significantly reduce equipment damage. Several factors contribute to lightning damage. Geographical location plays a role, as sites in areas with high lightning activity are at greater risk. Site elevation matters too, with mountain-top sites being particularly vulnerable due to their higher exposure. Site design is another factor, as poorly designed sites can attract lightning strikes. Equipment grounding is critical because inadequate grounding can provide a path for lightning currents to damage equipment. Transient voltage surge suppressors, also known as TVSS, can protect equipment from voltage surges caused by lightning strikes, but their effectiveness depends on proper installation. Key elements of an effective LPS include firstly, a thorough site assessment to identify potential lightning hazards and vulnerabilities. Secondly, appropriate lightning arresters, meaning the installation of high-quality lightning rods or air terminals and conductors. Thirdly, a comprehensive grounding system, ensuring all equipment is properly grounded using low-resistance materials. Fourthly, surge protection devices, or SPDs, which involves installing TVSS to protect equipment from voltage surges. And fifthly, regular inspections and maintenance to inspect and test the LPS regularly to ensure its integrity. For strategic LPS designs for mountain-top sites, consider the following. 1. Early streamer emission, or EES, lightning rods. These rods emit streamers that attract lightning strikes, increasing the protected area. 2. The rolling sphere method. This determines the minimum radius of protection required and install lightning rods accordingly. 3. Multiple grounding points. Install multiple grounding electrodes to reduce the risk of ground potential rise. 4. Cathodic protection. Apply protective coatings to metal surfaces to reduce corrosion and improve grounding. By implementing a comprehensive LPS that addresses the specific vulnerabilities of mountain-top transmission sites, it is realistic to aim for significant reduction in lightning damage to equipment, approaching zero incidents over an extended period. It is important to remember that lightning protection is a system, not just a collection of parts. All components must be properly installed and maintained to ensure optimal performance. Regular inspections are necessary to identify and address any potential problems before they lead to equipment damage. Consider also the specific equipment being protected. Different types of equipment have different voltage and current surge tolerances. The TVSS and other surge protection devices should be selected based on the sensitivity of the equipment being protected. Furthermore, it is advisable to consult with experienced lightning protection professionals. Designing and implementing an effective LPS requires specialized knowledge and experience. Consulting with experts can help ensure that the system is properly designed and installed. Also, keep up to date with industry standards and best practices. Lightning protection technology is constantly evolving. Staying informed about the latest standards and best practices can help ensure that the LPS is up to date and effective. Consider a layered approach to protection. A layered approach combines different protection methods to provide comprehensive protection. This may include lightning rods, grounding systems, surge protection devices, and shielded cables. Consider the surrounding environment. The surrounding environment can affect the effectiveness of the LPS. For example, trees and other structures can provide a path for lightning strikes to reach the equipment being protected. Ensure that the LPS is designed to address the specific challenges posed by the surrounding environment. Educate personnel on lightning safety. It is important to educate personnel on lightning safety procedures. This includes knowing what to do during a lightning storm and how to report any damage. Document the LPS. Keep detailed records of the LPS, including its design, installation, and maintenance. This information will be helpful for future inspections and repairs. Consider future expansion. When designing the LPS, consider future expansion. The system should be designed to accommodate any future equipment additions or changes to the site. Review and update the LPS regularly. The LPS should be reviewed and updated regularly to ensure that it is still effective. This is especially important if there have been any changes to the site or the surrounding environment. Bear in mind that a good grounding system is essential for lightning protection. The grounding system should be designed to provide a low impedance path for lightning currents to flow to ground. This will help to prevent damage to equipment and personnel. Surge protection devices, or SPDs, are designed to protect equipment from voltage surges caused by lightning strikes and other events. SPD should be installed at the service entrance, at distribution panels, and at individual equipment locations. Shielded cables can help to protect equipment from electromagnetic interference, or EMI, caused by lightning strikes. Shielded cable should be used for all critical circuits. Lightning rods, also known as air terminals, are designed to intercept lightning strikes and conduct the current to ground. Lightning rods should be installed on all high points of the structure. Dam conductors are used to connect lightning rods to the grounding system. Dam conductors should be made of low impedance materials and should be installed in a way that minimizes the risk of damage. Grounding electrodes are used to provide a connection to the earth. Grounding electrodes should be made of corrosion-resistant materials and should be installed in a way that provides a low-resistance path to ground. Bonding is the process of connecting different metal parts of the structure together to create a common ground potential. Bonding helps to prevent voltage differences that can cause damage to equipment and personnel. Lightning protection zones are used to divide the structure into different areas with different levels of protection. Lightning protection zones can help to reduce the risk of damage from lightning strikes. Lightning warning systems can provide early warning of approaching lightning storms. Lightning warning systems can help to protect personnel and equipment from lightning strikes. Lightning risk assessment is the process of evaluating the risk of lightning strikes to a particular structure or area. Lightning risk assessment can help to determine the appropriate level of lightning protection. Maintenance and inspection are essential for ensuring that the lightning protection system is working properly. The lightning protection system should be inspected regularly and maintained as needed. The grounding system should be tested regularly to ensure that it is providing a low resistance path to ground. The surge protection devices should be tested regularly to ensure that they are functioning properly. The lightning rods and down conductors should be inspected regularly for damage. The lightning protection system should be updated as needed to reflect changes in the structure or the surrounding environment. Implementing a comprehensive lightning protection system is a complex undertaking. It is important to work with qualified professionals to ensure that the system is properly designed, installed, and maintained. Consider the long-term costs of lightning damage. Lightning damage can be very costly, including the cost of repairing or replacing damaged equipment, the cost of downtime, and the cost of insurance premiums. A comprehensive lightning protection system can help to reduce these costs. Consider the safety of personnel. Lightning strikes can be deadly. A comprehensive lightning protection system can help to protect personnel from lightning strikes. Consider the value of the equipment being protected. Some equipment is more valuable than others. A comprehensive lightning protection system can help to protect valuable equipment from lightning strikes. Consider the importance of the function of the equipment being protected. Some equipment is more critical than others. A comprehensive lightning protection system can help to protect critical equipment from lightning strikes. Consider the potential impact of downtime. Downtime can be very costly. A comprehensive lightning protection system can help to reduce the risk of downtime. Ensure the grounding system resistance is low, ideally below 5 ohms as per industry best practices in electrical codes. The lower the resistance, the better the grounding system's ability to dissipate lightning current. Use exothermic welding for grounding connections. Exothermic welds create a permanent, corrosion-resistant connection that is superior to mechanical connections for grounding systems. Install surge protection at multiple levels. Cascade surge protection by installing SPD at the service entrance, sub-panels, and sensitive equipment to provide layer defense against surges. Implement a regular inspection program. Conduct visual inspections and electrical testing of the lightning protection and grounding systems at least annually, and after any significant lightning events. Use calibrated test equipment to verify the effectiveness of surge protection devices. Infrared scanning can identify hotspots in electrical panels, which may indicate loose connections or overloaded circuits that can exacerbate lightning damage. Ensure proper bonding of all metal components. Bond all metal components such as pipes, conduits, and enclosures to the grounding system to minimize voltage differentials and prevent side flashes. Use shielded cabling for sensitive circuits. Shielded cables provide an additional layer of protection against induced surges and electromagnetic interference. Consider using fiber optic cables for critical data communication links. Fiber optic cables are immune to electromagnetic interference and can provide a reliable communication path during lightning events. Implement a lightning warning system. A lightning warning system can provide early warning of approaching lightning storms, allowing personnel to take protective measures and shut down sensitive equipment. Conduct a lightning risk assessment. Perform a thorough lightning risk assessment to identify vulnerabilities and determine the appropriate level of protection for the site. Ensure compliance with relevant standards. Adhere to applicable lightning protection standards such as IEC 62305 or NFPA 780 when designing and installing the lightning protection system. Train personnel on lightning safety. Provide training to personnel on lightning safety procedures, including what to do during a lightning storm and how to report any damage. Document the lightning protection system. Maintain detailed documentation of the lightning protection system, including its design, installation, testing, and maintenance. Review and update the lightning protection system regularly. Review and update the lightning protection system periodically to ensure that it remains effective and meets the changing needs of the site. By following these recommendations, you can significantly reduce the risk of lightning damage to equipment and personnel at radio and television transmission sites. Consider the soil type. The soil type can affect the effectiveness of the grounding system. Sandy soils are more conductive than rocky soils. If the soil is not conductive, it may be necessary to use ground-enhancing materials. Consider the water table. The water table can also affect the effectiveness of the grounding system. If the water table is high, the grounding system will be more effective. Consider the climate. The climate can affect the effectiveness of the lightning protection system. In areas with high lightning activity, it may be necessary to use more robust lightning protection systems. Consider the age of the equipment. Older equipment is more susceptible to lightning damage than newer equipment. It may be necessary to upgrade older equipment to protect it from lightning damage. Consider the location of the equipment. Equipment that is located in exposed areas is more susceptible to lightning damage than equipment that is located in protected areas. It may be necessary to relocate equipment to protect it from lightning damage. Consider the type of equipment. Some types of equipment are more susceptible to lightning damage than others. It may be necessary to use special lightning protection measures for certain types of equipment. Consider the cost of the equipment. The cost of the equipment should be considered when determining the appropriate level of lightning protection. Consider the value of the data that is stored on the equipment. The value of the data should be considered when determining the appropriate level of lightning protection. Consider the impact of downtime on the business. The impact of downtime should be considered when determining the appropriate level of lightning protection. A comprehensive lightning protection system is an investment that can save a company money in the long run. Lightning damage can be very costly, including the cost of repairing or replacing damaged equipment, the cost of downtime, and the cost of insurance premiums. A comprehensive lightning protection system can help to reduce these costs. The initial cost of a lightning protection system may seem high, but it is important to consider the long-term benefits. A lightning protection system can protect equipment, data, and personnel. It can also reduce the risk of downtime. A comprehensive lightning protection system is a wise investment for any company that operates radio and television transmission sites. While aiming for zero lightning damage incidents might be an aspirational goal, it's more pragmatic to focus on significantly reducing the frequency and severity of such events through a robust and well-maintained lightning protection system. Regular review and adaptation of the system are crucial to maintaining its effectiveness over time.